All right, let's dive right into this explainer. Today, we are following the incredible, somewhat chaotic journey of raw employee survey data, watching it transform from a messy pile of feedback into highly actionable, predictive business insights. Look, we all know employee engagement is absolutely critical, right? But let's be honest, human resources departments constantly struggle to make sense of the overwhelming amount of feedback they actually collect. So we're going to pull back the curtain and look at exactly how data professionals build an end-to-end analytical pipeline to solve this exact problem. Here is our roadmap for the journey today. We'll start with the HR Data Challenge, move through cleaning the messy data, tackle statistics and hypothesis testing, decode text with NLP, and finally, build out predictive models and dashboards. So first up, Section 1, the HR Data Challenge. To solve the massive headache of mixing quantitative ratings with qualitative, open-ended comments, we rely on a truly powerhouse Python data stack. Pandas acts as our rock-solid foundation for data manipulation. Then, SciPy steps in with the mathematical frameworks we need to determine statistical significance. For all those unstructured, open-ended employee comments, we use NLK, the Natural Language Toolkit. Next up, scikit-learn serves as our machine learning engine to build out classification models. And finally, Streamlit comes in to transform all of that static analysis into beautiful, interactive web applications. Our core mission here is simple but absolutely crucial. We have to stop making decisions based on statistical noise and start extracting the real, authentic drivers of employee satisfaction. A typical HR survey usually gives us a messy mix of 1 to 5 Likert scale ratings and unstructured qualitative text. To get any true value out of that, a data analyst has to rigorously process these totally different data types in tandem. It's not just about finding basic averages anymore. It's about uncovering complex, multivariable interactions. Moving right along to Section 2, cleaning the messy data. Because as we know, data rarely arrives ready for machine learning. We have to take these disconnected, messy CSV files and progress them into a unified, mathematically viable data set. Usually, HR data exists in completely separate tables. You might have one for demographics and a totally separate one for the actual survey responses. So, we start by merging those data sets together using the employee ID. But of course, missing values can completely crash our algorithms, so we have to impute those missing numbers, replace null text fields with empty strings, and then calculate composite scores to define broader dimensions like overall company engagement. Now here is a really crucial point. When you're dealing with missing values, choosing the median over the mean can literally save the integrity of your survey's rating scales. Mean imputation is incredibly simple, sure, but because Likert scales are ordinal, meaning they represent categories like 1 to 5 rather than continuous fluid numbers, taking a pure average might give you a mathematically awkward score like 3.2. Nobody rates their satisfaction as a 3.2. That's why median imputation is typically the vastly superior choice for this specific type of data, ensuring we maintain valid, logical scale values. Up next is Section 3, Statistics and Hypothesis Testing. With a clean foundation, we can start exploring the hidden mathematical relationships. When we ask a question like, does satisfaction truly differ across departments? We need the absolute right statistical test to give us the answer. And for survey data, the Crisco-Wallace test usually wins out, simply because it doesn't assume a perfectly normal distribution. ANOVA is great for testing the means of 3 or more independent groups, but it assumes your data follows a perfect bell curve. Let's be real, human survey data almost never does. The Crisco-Wallace test is a non-parametric alternative. It evaluates the ranks and medians of groups, making it a much safer, more rigorous choice for finding out if, say, the engineering department is statistically less satisfied than the marketing department. Section 4, Decoding Text with NLP. Quantitative data is great for telling us what is happening, but we need natural language processing to tell us why. To unlock the hidden value in those open-ended text comments, we use something called TF-IDF. This essentially shines a spotlight on rare, high-impact words like overworked. Think of it like this. If a word like overworked is super rare in the overall dataset, but it appears heavily in one specific employee's comment, TF-IDF flags it as carrying a really high importance weight. This allows our machine learning model to actually learn from specific impactful vocabulary, rather than just blindly counting how many times words are used. By following these exact pre-processing steps, we strip away all the noise and convert messy human language into a structured numerical sentiment score that bridges the gap to our mathematical models.
We start by lowercasing absolutely everything. Then we strip out the punctuation using regular expressions, and we split the strings into lists of words, a process known as tokenization. After we throw away the semantic fluff, words like the and, we run it all through Vader to assign a mathematical sentiment score ranging from -1.0 to +1.0. Just like that, human emotion becomes a numeric column in our pandas data frame. And finally, Section 5, Predictive Models and Dashboards. We've reached the climax of our data's journey, where we finally feed our engineered features into a predictive model.
Look, it's pretty easy to just train a random forest classifier, but the most valuable output for HR isn't just the prediction itself. It's answering this pivotal question. Predicting that an employee has low satisfaction is helpful, sure, but understanding why they feel that way is what actually empowers leadership to fix the company culture. We have to identify the strongest predictors of our target variable. Here is a massive trap you have to avoid. Because HR data is notoriously imbalanced, usually flooded with mostly high satisfaction ratings, you absolutely must use balanced class weights and evaluate your model using the F1 score. This prevents your model from just lazily guessing high every single time. Think about it. If 90% of your employees rate their satisfaction as high, a lazy machine learning model could just guess high for every single person and still technically be 90% accurate. By adjusting those class weights and focusing on the F1 score, which balances precision and recall, we force the model to genuinely learn the complex multivariable interactions hidden deep in the data. When we extract the feature_importances array from our scikit-learn model, we discover something fascinating. Manager effectiveness is actually the heaviest weight driving company morale. When we map the weights back to the survey questions, manager effectiveness leads the pack at 0.45, followed by work-life balance and career growth. The tree-based random forest model absolutely excels at this, teasing out exactly which factors are pulling the strings behind the scenes. Now, all of this incredibly complex pipeline work ultimately manifests in an interactive Streamlit dashboard. We cache the clean data and create simple sidebar widgets so that HR leaders can immediately visualize key metrics. They can see total respondents, sentiment scores, and satisfaction distribution all at a glance, without needing to know a single line of Python. This entire hero's journey culminates in data-backed strategic recommendations exactly like this one, directly linking our Python algorithms to real-world human resource actions. The executive summary isn't just a boring list of statistics, it's a compelling narrative. Because our model proved that manager effectiveness is the top driver, and our Kruskal-Wallis test proved the engineering department is statistically lagging in this exact area, we can confidently advise a multi-thousand-dollar investment in leadership training. No more guessing. If a structured pipeline can uncover such profound hidden truths in your company's survey data, imagine what else is out there. We've seen how tools like Pandas, scikit-learn, and NLTK can completely revolutionize how an organization actually understands its own people. By moving past the statistical noise, we finally hear what employees are really saying. Thanks for joining me on this explainer. It really makes you wonder, what unstructured data in your own life is just waiting for the right pipeline to reveal its true story?